Hello, fellow Scratchers! Do you want to make a Zelda-style RPG in Scratch? Well, this is the place to be! If you've managed to catch any of my RPG devlog videos, then you'll know what's in store, and I can tell you it's really exciting. Not only do we have scrolling tiled maps, but the tiles are layered to support height and depth. We have a fully animated player sprite as well as animated tiles to bring your levels to life. We'll implement clever per-tile collision regions so that we can get up close to our levels and also allow us to move in front and behind tiles. How cool is that? And wow, don't get me started on the awesome built-in level designer. That's just crazy cool. Have you ever seen anything like it in Scratch before? And look at all these beautiful tile costumes. We have over 500 of them. What? That's crazy! A huge shout out to the pixel artist Lobster for these. And you can find all of them in a Scratch starter project, linked in the description under this video. However, if you prefer to use your own costumes or source them from elsewhere, then that is just great. Everything will work just fine. Now, obviously, we have a lot of fun things to cover in this series, but we have to start somewhere. And today, in episode 1, we will be focusing on the player. Specifically, adding a solid game loop to carry us through the entire series. And then player controls and movement, getting that diagonal movement to work just right, not too fast and not too slow is the real trick. Stay tuned to learn how we fix that. And finally, we'll add in that lovely player animation, getting things looking really pro. Costume naming is key, so make sure to stick around until the end of the video to learn my clean and concise coding tricks. Are you ready for this? I know I am. Guys, let's get scratching. We'll begin by checking out the Starter Asset project. Click the link in the description under this video, or you can find it by visiting my Griffpatch Tutor account on Scratch. The first time you visit the page, you'll need to give it time to load, as it's got lots of assets, and I mean a lot of assets in there this time. If we look inside, we have a player sprite. No scripts, but plenty of very cool costumes. These ones I downloaded from opengameart.org, and all the credit goes to the user Veriel. You'll find all the costumes are designed to face in 4 directions, up, down, left and right, and they are all animated beautifully. Yeah, really cool. These we'll be using today, but there's a lot more in this asset project to look forward to. The tile sprite alone contains 500 costumes. Wowzers! Each 16 by 16 tile was hand-drawn by the awesome pixel artist Lobster, and wow is he good. So a huge shout out to him for making this resource available to us. Thank you, man. Moving on, you'll find I've made a pleasant pre-tiled background sprite full of grass. Yep, useful. Then we have a neat font sprite. You can refer to my text engine tutorials to learn how we are going to make use of this later on in the series. Lastly, we have the asset project thumbnail. Yeah, we won't be needing that. Right, so let's hit remix, and we're ready to go. This is the Scratch RPG Episode 1. The first thing I'm going to do is just click on the thumbnail sprite and hide it. Oh wow, look at the size of that player sprite. Click back into the player now. Shall we do some coding? When green flag clicked, we want to set things up, so start by setting the sprite size to 200, and then click that script. Here we go. So the first thing you'll notice is that all the graphics in my RPG have that retro pixel art vibe. A size of 200% means that we see all the details. That's so cool. Next up, we'll make the player face us. Switch costume to. So now is probably a good time to talk about how we've named these costumes. The first part of the name indicates the action being performed by the player. Idle means they are just standing still. The next number indicates the direction they are facing. I've used the standard Scratch directions here, so 0 is up, or north if you like, 90 is right, 180 is down, and -90 is left. Just the same as the direction numbers here. So, to face the camera, we want the idle 180 costume. Back in the code, switch to the idle 180 costume. So that covers size and costume. Next up, we need to talk about the sprite's position. For single screen games, we have the luxury of only having to consider a sprite's position on the Scratch stage. But for scrolling games, we need to keep track of the player's X and Y position on the entire level map. For this reason, we have to create two new variables. Player X for all sprites. Now, as a helpful hint, you might notice that I always use fully uppercase letters in my variables that are for all sprites. And now we need to create another variable, player Y, also for all sprites. We'll start the game by setting player X to 0 and set player Y also to 0. Great. For now, that's the setup done. Next up, we want to begin our main game loop. This is where all the action takes place, the controls are checked and the player is moved, and then we update the screen. One thing you learn real fast when coding game engines is that we'll always need a way to start, pause, stop and restart these game loops. So, broadcast a new message, start-game loop. It's nice when the event name is pretty self-explanatory. I'll drop in a when I receive start game loop in preparation for all our coding. But before we go on, let's consider the stop game loop code. When I receive a new message, stop game loop. And we can simply drop in from the controls category a stop block. And we want to stop other scripts in Sprite. If ever we broadcast stop game loop, we can be sure this will do the job. Cool, so let's build the main game loop. Bring in a forever block. The only thing that will stop this loop is that stop game loop event. Now we are going to use the same broadcast system we've used in many of my other tutorials here. The first broadcast is a new message of tick player. And the second is for paint player. In summary, this will run the tick player scripts first, and then the paint player scripts next, before Scratch then hits the end of this forever loop and the frame is complete. At this point, the game screen updates to show the changes before this loop starts all over again. The benefit of using this broadcast system is that it also allows us to synchronize our game loop across all the sprites in our game. Right now, we are only working with the player sprite, but later on, we'll be adding the tiles, NPCs, and who knows what else, so we can look forward to all of that in future episodes. Quickly tidy up then, and we'll begin by coding the when I receive paint player. It would be hard to work on the rest of the scripts if we can't see the player painted to the screen. And for now, until we actually have a scrolling level, we'll use a motion set X position to, and the variable player X. And we can have a set Y to, and the variable player Y. What this means is, if we were to switch the player X reporter to be a slider variable, then we can run the project and ta-da! The player's position is linked to the player X variable. This shows that the game loop is working perfectly. We can do the same with the player Y to check that it's working too. That's great! Also, if we stop the project without the game loop running, you'll see that the sprite's position is no longer updating. So our next job will be to add keyboard controls for our player. When I receive tick player. And yes, first we detect the keyboard controls, so make a new custom block to keep our scripts tidy. Name it player controls, and tick to run without screen refresh. Have you seen my crazy cool joysticks tutorial? If not, then it may be worth giving that a watch. You may even want to add it to this project. The reason I ask is that we need to implement 4-way movement, and this is best described by the movement of a joystick. A joystick has 2 axes of movement. Joystick X is for left or right, and joystick Y is for up and down. We'll replicate that in Scratch using 2 new variables. Joy X, joystick X, for this sprite only. And Joy Y, also for this sprite only. For starters, let's set joyx to, from the sensing category, key pressed. We need to look for the right arrow key. If you run the project here, you'll find that the joyx variable now toggles to true when the right arrow is pressed and false when it's not. Now, many times players will want to support the WASD keys, WASD, as well as the arrow keys. For that, we can use the OR block and set joyx to key right arrow pressed or key D pressed. Now, pressing either of these keys causes joyx to become true. That's excellent. So how about the left key? Duplicate the OR block and change the keys to left arrow and the A key. And here comes the fun bit. We change joyx by 0 subtract the left or A key presses. The interesting thing about these true and false key presses, or in fact any true or false values, is that as soon as you use them in calculations, the true value gets counted as a 1, and the false values become zeros. So, if we press the left arrow only, then this second change will subtract 1 from joyx. Looking at the running project, pressing right gives a value of 1, and left -1. Perfect. Let's do the same for joy y. Set joy y to the key up arrow or the W key. Changing joy y by 0, subtract the down arrow or the S key. Great! We can just test that works okay by slapping that green flag and confirm we can toggle the left, right, up and down keys and the W, A, S and D keys. Nice work. It won't be hard to get our player moving around from this. Come back to the when I received tick player script and we'll make a new custom block naming it try move with an input named dx and another dy. This is the distance we want to move in. Tick to run without screen refresh. So we'll make use of this new block right away, right after checking the player's control keys, and pass in the resultant joyx and joy y values. Now, this define try move script. Later on we will need to perform collision detection and the like in here, but for now, let's simply move the player without worrying about such things. Change player x by the dx input. And of course change player y by the dy input. Splendid! Smash that green flag! Holding down any of our direction keys should now send a player, well, it's fair to say they are hardly hurtling around the screen, but it's fantastic that we've got movement in all 8 directions, that including diagonals now. Do check each direction of movement. If any key moves the player in an unexpected way, then now is the time to double check your scripts before moving on. If you want a bit more speed to your player's movement, and I certainly do, then we'll do this in the tick player script. Just multiply joy x by 5 and multiply joy y by 5. Now here's an interesting thing. You may have noticed, while playing other top-down games on Scratch, that moving diagonally can make your player move considerably faster than just moving left or right alone. This is because, if we consider our joyx and y values, before we added our multiply by 5, moving up or right individually moves us a distance of 1 pixel. But when we move both up and right at the same time, the distance travelled is actually closer to 1.4 pixels, and that is 40% faster. To fix this, we need to normalise the joystick movement speed to account for these diagonals, and the way we do this is to divide the joystick x and y by the distance. A spot of Pythagoras will give us that, and there, that looks perfect. Back in our code then, make a new variable joy_dist for distance, and for this sprite only. Then set joy_dist to the square root of, I'm bringing in a sum operator, and 2 multiply blocks, and we want joyx multiplied by joy x, and joy y multiplied by joy y. Cool. Pop these in either side of the addition. That gives us the true distance, and we can test that by running the project and checking what values appear when we move around the screen. We should see zeros and ones, and 1.414214 for the diagonals. Also, see how the distance is never negative, even when moving left or down? That's quite useful, actually. So come back to when I receive tick player script. Bring in an if-else around the try move. There's no point now trying to move the player if no key has been pressed. And now we can easily check for this when joy distance is greater than 0. Why not just give that a quick playthrough to ensure that nothing has gone awry? And yes, I can still move around just fine. Okay, so next up, we are going to be dividing the joystick movement by this distance. The great thing about normalising is that whenever you divide something by itself, it always comes out as 1. So before we move, set joy x to the result of dividing the existing joy x by joy distance. And we do the same for joy y. Setting joy y to the result of dividing joy y by joy distance. Right, that's how we normalise. Shall we give it a test? Oh, this is great. The normal x and y movement is unchanged, but the diagonal speed has been reined right in and we can travel at a very consistent pace. What do you think? It's funny though, but many people can actually find this change feels like it's gone too far. I guess we are so used to the faster diagonal movement that the reduced pace can feel a little bit sluggish. So much so that even games like Zelda actually implement a special diagonal speed that is just that little bit faster than what we have here. We can do the same if you like, just by popping in an if block before the set joy x here. Check if joy dist is greater than 1. And if it is, then it's definitely a diagonal. So to compensate, we set joy dist to 1.25. That's instead of the 1.4 value. Give that a test and see what you think now. Yeah, see, the diagonals are just a little bit more speedy. If it's good enough for Nintendo, it's good enough for me. Okay, we are making great progress. What would be cool though is for us to next begin using our players' costumes. If you look in the Costumes tab, the first 4 costumes are for our player, idly facing north, east, south and west. Their costume names begin with the word idle, followed by the direction 0, 90, 180 and minus 90. The next costumes are for walking, and no surprise we find walk 90 as the first costume name for walking right. This is followed by 5 more costumes, 6 in all, to animate our player's walk cycle. So, to make use of these sprites, we will need to know what direction the player is facing. Back to the code then. We'll need more space to code this in, so take those movement scripts out of the tick player receiver and wrap them in a new custom block. Player movement. And tick the run without screen refresh block. Pop those scripts in the define block and make use of the block from where we pulled it. Great, so to tell what direction we are facing, use an if-else block and check if joy x is less than 0. That means we're facing to the left. Make a new variable. Player dir for direction. For all sprites. And set player dir to -90, that is left. Next up, duplicate that if and check for joy x being greater than 0. And set player dir to 90, that's to the right. Okay, so duplicate the whole thing and switch to look for joy y being less than 0. That means we can set player dir to 180, because that's the down direction. And then, well, if none of the above, it has to be up. So we can scrap the last if check and simply set player dir to 0. That's up. Those last ifs go inside the else here. Cool. Give the green flag a tap and confirm that the player dir is being set to each of the 4 values 0, 90, 180 and negative 90 as we move around the screen. That's wonderful because that means we are free now to set our costume. Switch costume 2. Now remember our costume starts with the word walk, so we need a join block and enter the word walk in the left hand side. And on the right, drop in the newly set player dir variable. And I can't wait to see this! Smash the green flag! Oh yes, this is really starting to take shape. That makes a huge difference. But you wait until we add the actual player animation, their walk cycle, that will be the icing on the cake! Well, for player animation, we almost always resort to using a frame variable. This is by far the easiest way to keep track of things, so make a new variable named frame for this sprite only. And we change frame here in the player movement script. This means it doesn't change unless we are moving. But rather than changing by 1 to go onto the next frame directly, that would just be too fast. Change frame by 0.3 instead. This means it will take roughly 3 ticks of our game loop before we change costumes. Feel free to play around with this value as you see fit. Now, we can't go adding this frame number to a costume name, but if we switch to the first costume like we already have, then we can now get back the costume number using this block. See? And that means we can now add the frame to this to create our animation. We need a new variable to hold the current costume number, call it base costume, as it's the base costume that we'll animate from. Make it for this sprite only. So right after switching to the new costume, we can set base costume to the new costume number. If we run the project, you can see that the base costume number is being set, along with the frame variable increasing and increasing. But I don't want to actually set the final costume in here. The final costume change can be done in the when I receive paint player script up here. So make a bit of space, and we then switch costume to. We'll need to sum the costume with the frame, so drop in an addition block, and on the left, the base costume variable. On the right, yes, we want the frame variable, but guys, it's not enough to drop it directly in there, otherwise you'll find your player dancing around like a crazy thing, and that's because there are only 6 costumes per animation. But frame is increasing way further and trundling through all the costumes this sprite has available to it. We need to constrain this loop to just 6 frames. The block for this is called mod. And however many costumes you have in your character animation, that is the number you place on the right of the mod block. That's 6 if you're using my starter asset project. On the left, we would drop in frame, but first we need to ensure we ignored the fractional part of this number. If you look, frame currently is 231.60000, goodness knows where all that imprecision came from. So drop frame into a floor operator. And now the number gets rounded down to 231. Oh, that's much better. Drop that in turn into the mod 6, and now we'll only get values between 0 and 5 out of this, which is perfect. And we can plonk it carefully into the right-hand side of the switch costume here. And here goes nothing. Green flag time. Sweet animation. Look at that. This guy's got a very satisfying bob to his walk, don't you think? It's so cool that we can now animate this player in all directions by using a bit of clever costume naming. So we are almost done for this episode, but you may notice that although the walking animation is now working great, when the player comes to a halt, things are not so good. The player just freezes mid-walk, and some of those animation frames do look really weird when caught mid-walk cycle. What we need to finish with is adding in those idle costumes. And as luck would have it, if you look at the when I receive tick player script, we already know the player is idle when the joystick is not pressed. And that would be in this empty else condition. So if you like, we can duplicate the switch costume blocks from the define player movement script down here, as they are very similar to what we need here. Bring them back up to the tick player script and into that empty else branch. Only rather than switching the costume to walk, we now switch to idle. The direction we leave as is, whichever direction the player was last facing. And now this change frame, our player has no idle animation cycle. So for me, instead of changing frame, let's set frame to 0 instead. Now that's not a change frame, that's a set frame to 0. Good. Cool, that should be it. Click the green flag with me one last time. And now after we finish walking, the player should return to their idle standing pose. Yeah, that looks sweet. I can do little shuffle movements and the animation plays along perfectly. Isn't that great? Let me just hide those available reporters and we are done. Well, I hope you enjoyed this video. If you did, then please smash that like button and don't forget to subscribe to this channel because the next episode will be here before you know it, and man, it is going to be awesome as we begin to build our tile stamping engines. If you want to get these episodes earlier, then you can consider joining the channel membership. Not only does that directly support the making of these videos, but you get membership perks like channel emoji, priority replies to comments, early access to videos, and if you want, access to the projects themselves. How cool is that? But I'm afraid that's all I've got time for today. So have a great week ahead, and scratch on, guys.